So we're going to take a look at multiplying a binomial times a binomial. So the one thing that's nice about multiplying a binomial times a binomial is it's really not that much different than your normal distribution problem. So your normal distribution problem has, say, for example, 2x times 4x minus 7. And you're going to take what's on the outside and distribute it, the term on the outside, and distribute it through to all the terms on the inside. Right? Well, in a binomial times a binomial, there are two terms on what we might consider the outside. And so instead of distributing one thing, we're just going to be distributing two things. So I often refer to this as double distribution, and we're simply going to distribute and then distribute again. And I'm going to show you the best way to kind of organize this to make sure that in the end, our work is going to be neat and help us organize to get to the correct answer. Okay, so we're going to just start by distributing through our first term, this x term. Okay, so x times x is an x squared. X times 3 we would write as plus 3x. Okay, now we have a second distribution. We need to distribute a positive 6 to both terms in here. Okay, 6 times x is 6x. So what I'm going to do is set this up sort of like our old school addition problems. I'm going to write like term under like term so that when I combine, I can just add straight down. So 6x is a like term with 3x, so we'll write them underneath each other. Then 6 times 3 is 18. Okay, so now what we can do is just draw a little line and add straight down to combine like terms, because when we're combining like terms, we're just adding. X squared plus nothing is just x squared. 3x plus 6x is positive 9x. Nothing plus 18 is just 18. And there, we're done. Okay, so we're going to keep doing this for a couple. We're going to take a look. We're going to skip around a little bit because I don't think we need to do all of these examples. We're going to take a look at about half of them. And we're just going to focus on ones that might be a little bit unique. Okay, so we're going to take a look at 3 and 4. So we're going to double distribute. We're going to do our first distribution, distributing our first term through and multiplying it to every term in the second binomial. So we're going to get x times x is x squared. X times negative 4 is going to be a minus 4x. Okay, second distribution. Now, just careful, this is a negative 10, right? We always look to the left of the value, be it a monomial or a constant. Well, a constant is a monomial, but so something with or without a variable. To the left of it is where you're going to see the sign, positive or negative. So we're distributing a negative 10 to both terms. And we're going to write like terms under like terms. So negative 10 times x is a negative 10x. Negative 10 times negative 4 is a positive 40. Okay, now we have both of our distributions done. So we just need to combine like terms by adding straight down. So we would get x squared, negative 4x plus negative 10x is negative 14x. And then lastly, a plus 40. Okay. So you just want to double check that at the end, all of your like terms are combined so that you know that you're as simplified as you can be. Okay, let's take a look at this one. Now this is a little different because if we look at this polynomial, we have an x squared term in our second one, which we haven't had before. So let's see if that changes anything or if it's just something a little bit extra that doesn't really change anything. So I'm going to start by distributing, just like I did before. So 2x times 3x squared is a 6x cubed. 2x times negative 4 is minus 4x. Oops, excuse me, 8x. All right, we're going to keep going. 5 times 3x squared. Well, that's a negative 15 or a positive 15x squared. Well, we don't have any x squared, so I can't write it under either of these terms. It has to kind of start its own little space here, 15x squared. And then finally, 5 times -4 is minus 20. So this one was a little bit unique because we don't have any like terms to combine. So when I add straight down, we're going to get 6x cubed minus 8x plus 15x squared minus 20. But we're not quite done because this is not in standard form, and we should always write polynomials in standard form. So we want to go from greatest exponent to least. So this should be 6x cubed plus 15x squared minus 8x minus 20. Once we're in standard form, then we're complete. All right, let's take a look at two more. So we're going to do number 6 and number 8. Okay. So number 6, here we have multiple variables. We have x and y. That's all right. We're just going to go through and see what we get. So again, first distribution, just taking that first term, distributing it to everything in the second polynomial. So we're going to get a 6x cubed plus 9, so 3 times 3 is 9, x times y. We don't have any other way to write that other than just xy. Okay? Nothing, don't try to overcomplicate that. It's just x times y, we just write it xy. Second distribution here. So now we have 2y times 2x squared. That's going to be 4yx squared. We don't have a term like that yet, so we're going to create its own little column, 4yx squared. And last one, 2y times 3y is going to be 6y squared. And again, it's the only term of its kind. So now we're going to go ahead and just combine like terms. 6x cubed plus 9xy plus 4yx squared plus 6y squared. We do still have to put this in standard form. So one thing with standard form is the degree of a term is the sum of the exponents. So this one right here, this 4yx squared, is actually a third degree term and should come before our 2 second degree terms. We have 2 third degree terms and 2 second degree terms. It doesn't terribly matter the order that the third degree terms are in, but you can always default to alphabetical order if you'd like. So x comes before y, so you can put the one with x in it before the one with y, but there's not really a standard operating procedure for that. So we're going to go 6x cubed plus 4yx squared plus 9xy plus 6y squared. So now we're in standard form and done. Okay, last problem. Let's go ahead and do our distribution. So first distribution. Okay, we're going to get 4x squared and then 2x times -5 minus 10x. Last distribution here. So then we're going to get 10x minus 25. All right, we want to add straight down. So we're going to get 4x squared, but then here we want to note that these are opposites, -10x plus 10x. Well, anything plus its inverse, right? Inverse property of addition is just 0. So there we just get 0. You can write a little plus 0 if you'd like, but we will have to simplify. Then we get minus 25. All right, we don't want to leave that 0 in there. So either don't write it in the first place because anything plus 0 is just itself, or we do need to then kind of combine like terms. So you have 4x squared, 0 minus 25 is just a -25. So there are a few examples of multiplying a binomial times a binomial. So we are going to take a look now at how to find a missing value in a binomial. And we're going to do this very similarly to how we did this with distribution, where we're just going to kind of ignore the missing value, do our distributions until the end of the problem, where we're going to take a look at what we're missing. So I'm just going to start setting this up just like any other binomial times a binomial. So I'm going to do my first distribution here, distributing this kx. So that'll be k times 2, x times x is x squared. Kx times -3 is going to be, I'm going to write this as plus k times -3x, right? So you think of k as just a number. So kind of pretend like it's 5 and pretend that it would do anything a 5 would do. So if we're taking 5 times -3, we would just write it as 5 times -3. So the fact that it's a k, we're just going to write it as k times -3, and we're just going to do addition there. All right, so now we're going to do our second distribution, and we're going to write our like terms under our like terms. So 5 times 2x is a 10x, so that's going to be a like term with anything with another x. So that's 10x. And then 5 times -3 is a -15. So now here's where things start to get a little bit different. Instead of trying to combine like terms, I already know what I should get when I do that because here's my answer. So I'm going to write that. My x squareds should be 8x squared minus 2x minus 15. Okay, so let's take a look at how we can find this k. There are actually two spots where I can find k. The first spot being right here, right, where those coefficients line up. And the second spot is right here, where those coefficients line up. So those are both columns that have k in them. I'm going to use the first column because it doesn't have anything that it's combining with. There's nothing in this little empty space right here, which is going to make it a little bit easier, okay? So that means what this is telling me is that when I take k times 2, it must equal 8. So we can use that to solve for k and find that k needs to equal 4. Okay. Now I'm going to show you how to do it with this other column, and we should get the same answer. So what this is saying is that k times -3 plus 10 needs to equal -2. Okay, so it's just a little bit more of a complicated equation, but it's still one that we can definitely solve. So we can subtract 10 from both sides. K times -3 needs to equal -12. Divide both sides by -3. K equals 4. So no matter which way we do it, we get the same answer. It's just you can strategically pick a direction that is going to make it a little bit easier on you if you want.